Good morning all. Recording of this particular lecture will be available to you for later viewing. In the last class, we had a discussion on the general behavior or the general introduction of VHDL. Now, in this particular topic, we shall discuss about the behavioral modeling. Uh, we shall be discussing the entity declaration architecture body, process statement, signal assignment statement, and the wait statement. In VHDL, there are three different types of modelings. That is, your VHDL program you can write in three different styles. The first one is the behavioral modeling, second one is the data flow modeling, the third one is structural modeling. Let me correct the echo problem. Uh, yes, am I audible now without echo?
Yes, sir.
Okay. So three different styles of modeling are there. That is in VHDL, that is behavioral modeling, data flow modeling, and structural modeling. Uh, in this topic, we shall be discussing about the behavioral modeling. So the behavioral modeling of the entity is expressed using sequentially executed procedural type of code. So that is very similar in syntax and semantics to that of the higher level language code that you write in the C language or Pascal language or any other Java language. The a process statement is a primary mechanism used uh, to model the procedural type or the behavioral type of an entity. Uh, this particular topic describes the process statement and the various kinds of process statements that can be used within a process statement to model such behavior. Irrespective of modeling style used, every entity is represented using entity declaration and at least one architecture body. So in every VHDL program, you will be having entity declaration statement, at least one entity declaration statement, and an architecture body statement. And after that, the way you define that particular architecture body determines whether it is behavioral modeling or data flow modeling or it is structural modeling. So to begin with, let us see the entity declaration statement. To write any VHDL program, you need to know the structure or syntax of two different blocks. One is the entity declaration and another one is the architecture declaration. So first of all, let us see how entity declaration can be done in VHDL. An entity declaration describes the external interface of the entity. So what are the external interfaces that is declared in the entity declaration? So it gives the black box view of the entity. So if you it describes the circuit as a black box. It describes the external interfaces, that is what are the inputs and outputs of that particular circuit is declared by the entity. It specifies the same entity, the name of the interface ports, that is into the ports, they are either input or output pins, and the direction, that is whether it is input or output type of the port. The general syntax of the entity declaration is like this. The highlighted words, they are the keywords. That means they need to be used as it is. So entity is a keyword, is a keyword, generic is a keyword, port is keyword, begin and end, they are the keywords of the VHDL. So you need to use this particular keyword as it is. Uh, then entity can be declared in this fashion, entity. Then you can use any identifier to name that particular entity. So you can give any entity name. Is. Then in this entity declaration, you can declare the generic, that is the list of generic and their types. You can declare ports, so that is the list of the interface ports names and their types, and you can have the entity item declarations in this particular entity. Then you write the begin and you can write the entity statements in this, and at the end you write the end and the name of the entity. Okay. So in this declaration, the generic statement, so this is either you can write any one of this. Okay, so when you are going for entity declaration, so how this particular generic declaration is to be done, or how this entity item declaration is done, that we shall see later in the latter topics. In this topic, we shall be using only this particular port declaration. This port, with the port declaration, we declare which are the input and outputs of that particular entity. So in the example, it will be clear how you can declare this particular ports, that is the pins of that particular port. Okay. Even the entity statement also we shall see later. Okay. So in the simplest form, what we need to do is that we need to give some name to that particular entity, and then in the port we specify whether how many pins are there for that particular circuit, which are the input pins and which are the output pins. Okay, so this will be the simplest form of this particular entity declaration statement. In interface port, when you are declaring the interface port, then there can be four different modes in which you can define this particular port. So you can use in, which specifies the value of the input port can only be read within the entity model. That is, that particular value can be read only. Uh, Out means the value of the output port can only be updated within the entity model. It cannot be read. Whereas in out is the value of the bidirectional port can be read and updated within the entity model. Even there can be buffer, and in the the value of the buffer can be read and uploaded within the entity model. So that is how you can have the four different types for the pins or interface for a particular entity. Now let us consider one circuit which consists of AND gate, OR gate, and NOT gate. Okay, so this particular circuit we call it as AND or invert circuit. Uh, this particular circuit has got four inputs A, B, C, and D, and inside this some connections between the AND gate, OR gate, and NOT gate are done, and finally we have a single output called Z. Okay, so if we want to describe this particular circuit, then the entity statement for the circuit, it can be written like this: entity, then we can give some name to this particular circuit. uh, so the name given is AOI, so it is the short form for AND or invert. Okay, so because AND gate, OR gate, and an inverter is used, so the name given is AOI. So you can give some other suitable name also if you desire for this particular entity. Okay, then the keyword is, okay, entity AOI is. Then we just want to specify the ports for this particular entity, so we write only the port keyword inside this particular entity. That is in bracket, you need to write down the description of the input and output pins for this particular entity. The inputs pin are A, B, C, D. So you write A, B, C, D colon in, and you need to write its type, and its type is bit. Okay, so they are the bit type of pins. So the values taken by this A, B, C, D belongs to the bit type. The bit type has got two values, that is either 0 or it is 1. Then it is separated by the semi comma. The input list and the output list of interface is separated by a semi comma. Then the output interface is with a pin Z, single output is there, and Z followed by a colon, and out indicates that it is the output pin, and its type is again bit, so Z can take the value either 0 or 1. Then we define the end of this particular entity, and again you have to write the name of that particular entity, which is AOI. So this is how the entity declaration can be done for this particular given circuit. So uh, the point to be noted here is that this particular entity declaration, it specifies only the interface of this particular circuit. So interface meaning what are the inputs and what are the outputs of this particular circuit. The entity statement is not going to specify the functionality of the circuit. Okay, what is the functionality of the circuit? The functionality of the circuit is that two AND gates are there. Okay, that means A, B, C, D inputs are there, so it is going to perform the operation A and B, C and D. Then it is OR, so it is A, B or C, D, and a whole bar is there. Okay, so A, B or C, A, B or C, D whole bar is the functionality of this particular circuit. Okay, or how this particular circuit is composed, even that is also not specified in this particular entity statement. Okay, so the entity statement, it is only for uh, it is only going to show the interface or what are the inputs and outputs uh, of this particular circuit, but it is not going to specify the functionality. The functionality can be specified by the another block, and that is nothing but the architecture body. Okay, so the an architecture body describes the internal view of the entity, or it describes the functionality or structure of the entity. Okay, so how that particular entity works. is describe its functionality. Uh, so it can be described by using the statement, or you can write the structure for that. So different models are there to define the functionality or internal view of an entity. So the general syntax of the architecture body is like this. Okay, so as I have already explained, told you that for writing any of the VHDL program, you must know two syntax. One is the syntax for the entity, and another syntax is for the architecture. So the syntax of the architecture is like this: architecture. So this is the keyword. So you have to use this particular keyword as it is. The later the words in bold, they are all keyword. That means you need to use this particular keyword as it is. Okay, so architecture, then you have to give some name to this particular architecture. Okay, so architecture name, and this architecture is of the entity name. So this architecture you are describing the functionality. Okay, so this is in the architecture you are describing the functionality of which entity you are going to describe. So that entity name, the functionality of the entity of which you are describing is that particular entity name is to be given here. Okay, for example, we have already declared an entity AOI. Okay, so you can define some architecture which declares the functionality of that AOI entity. Then optionally you can have the items for the declaration here. Whatever there is done in the square bracket, it is optional. So you can optionally define architecture declaration. So this particular declaration, it will be available in this particular block from begin to end. This declaration, they can be constant, they can be variables, they can be signals. Then in the body of this architecture, you can write concurrent statements. You can describe the architecture of this particular entity, how or the functionality of this particular entity, by using various statements. What kind of statement this can be? It can be a process statement, it can be a block statement, it can be concurrent procedure call, it can be concurrent assertion statement, it can be concurrent signal assignment statement, it can be component instantiation statement, or it can be generate statement. So like this you can write the different types of statement. Of course we shall see all these particular type of statement. As far as behavioral modeling is concerned, you will be using the process statement to describe the behavior of your circuit. Okay, after you are describe or you are written all this statement to describe your circuit, then you write the end, and then you write the name of the architecture. Okay, so which you have already written here. Okay, so this is the syntax of the architecture body. Now the architecture statement describe the internal composition of the entity. So all these are the features of the architecture body. All architecture statement execute in parallel. So whatever statement you write there, they are executed in parallel. So it does not matter whether you write some statement first, or what you, the statement the any statement you write next. So all those statements, they are the concurrent statement. Hence their textual order appearance within the architecture has no impact on the implied behavior. Okay, so they are concurrent statement whatever you write in the architecture body. The internal composition of an entity can be expressed in terms of structure, data flow, or sequential behavior. So these are described using the concurrent statements. So we shall see the one example of this. The component instantiation are used to express the structure. The concurrent signal assignments statements are used to express data flow. So these are the different ways with which you can write the architecture body. So if you use the component instantiation, then it will be the structural type of modeling. If you use concurrent statement assignment, then it will be the data flow type of modeling. Whereas if you use process statement, then it will be a sequential style of the behavioral style of modeling, or it is also called sequential behavioral style of modeling the VHDL program. Okay, so each concurrent statement is different element operating in the parallel, in similar sense that the individual gates of the design are operating in the parallel. Okay, so whenever you are uh, drawing the circuits and you are drawing the gates, then individual gates, they are operating simultaneously whenever you are giving the input signal. So this is the example of the architecture statement. This particular style is the data flow style of the modeling. Okay, so already we have declared this particular entity statement. Name of the entity is AOI, and the inputs for this particular circuit or this entity, they are ABCD. For this particular uh, circuit, we have declared this particular entity, whereas the output is Z. Now the architecture declaration or architecture for this particular architecture can be statement can be written in this fashion. Architecture, you need to give the name to this particular architecture. So the name given is AOI underscore concurrent. Okay, because it is going to declare the data flow style of modeling, we have given the name AOI concurrent. You can give any other name. For example, you can give the name AOI underscore data flow for this. So appropriate name you can give for this particular architecture of, and it should be followed by name of the entity. The name of the entity is AOI here. Okay, then you have to write the keyword is. So of is a keyword, is a keyword. So it these particular keywords must be used in the similar fashion only. Then you write the beginning of the architecture with the begin keyword. Then you are writing a signal assignment statement. Of course, we shall be seeing the various statements later. So the signal assignment statement is like this: Z. Uh, this is the assignment statement. Then it is not in bracket A and B. Okay, so we are going to describe this particular circuit. How this particular circuit is should behave is described here in the form of the statement A and B. So we want to perform the operation on A and B. Okay, so A and B are the inputs here. Then A and B, or it is odd with what? C and D. Okay, so it is to be odd with C and D. Okay, both are put into the in the compound in the bracket. Okay, and a not operation is done on this. Okay, so finally you can see that whatever result comes, so that is the result of this particular circuit, the desired result. Okay, and it is assigned to Z, that is the output Z. So Z is assigned this, the output is assigned these operations on the inputs. So with only one statement, we have described this particular circuit. Okay, in the case if there are in the case if the circuit is complex, in that case you will be having more than one statement, or as many statement as you need. You can write between begin and end to describe this particular circuit. Okay, for example, uh, you could have declared some statements in between. For example, x x and y. Okay, for example, this particular signal you can write as x, and that is the uh, output of the AND gate you can write as X, first AND gate as X and output of second AND gate as Y. Then you could have written here that X is equal to A and B, and then Y is equal to C and D. Okay, so two different statements. X is equal to A and B, y is equal to c and d. Of course not it is equal to, but as it is the assignment statement that you need to use, and the statement need to be followed by a semi comma. Okay, like C language, every statement in the VHDL need to be followed by a semi comma. Okay, then followed by this particular two statements for x and y. Then we can have another signal which describe the at the output of the OR, which describe the output of the OR gate, for example W. So the next statement would be W is equal to X or Y, and and then finally the last statement would be Z is equal to not W. So like that you can write the number of statement, whereas all these they are done with the help of a single statement Z. Okay, now because you are using W, X and Y, so this W, X and Y signals can be declared in the declaration part of this particular architecture. Okay, so this is a short program you can say. Okay, so this is the program, VHDL program for describing this particular circuit, and the kind of modeling you are using for describing this particular program is the data flow style of modeling. Okay, now the it can be declared, or this particular program can be written in the other fashion, and that is the behavioral style of modeling. So this particular type of modeling is similar to writing a program which usually we write in higher level language. Okay, so in the behavioral style of modeling, you we use process statement. Okay, of course we shall see the declaration of the or the details of this particular process statement later. Okay, but to complete this particular program or to complete this particular architecture statement, that too by using the behavioral style of modeling, so the process statement has been used in this particular architecture. Okay, so now the architecture of AOI is defined. Okay, the name given is AOI sequential. Okay, now why sequential? Because the statements in this architecture now would be executed sequentially. Okay, whereas the if you do not use process, why they are executed sequentially? They are executed sequentially because we are using this particular process statement. Okay, so because we are using process statement, the statements within the process they are executed sequentially, whereas we are not using any process statement here. So whatever statement we write inside this particular body of the architecture, all these statements they are executed concurrently. Okay, concurrently in the sense simultaneously. Okay, that means continuously the x and y will be calculated, w will be also calculated, and z also would be calculated in this case. Okay, whereas this is the process statement, and in which the statements in this particular process are executed sequentially. Okay, so this is the sensitivity list. We shall come to this particular sensitivity list for the process later when we discussed process in the detail. Then this is the declaration for the local declaration for the process, that is these variables you can use inside this particular inside the process. Then begin, so this is the start of the process. Then you can make use of the variables which you are declared here. So how are we going to use this variable? So we are assigning temp1 is equal to, okay, you can note that inside the process you use the assignment statement in this fashion, colon equal to. Okay, whereas the signal assignment statement, there is a difference between the signal assignment statement. This is the signal assignment statement, greater than equal to is the signal assignment statement, whereas this particular assignment uh, in case of the process is colon equal to. Okay, so uh, this is we can say the variable assignment statement. Okay, so temp one is equal to a and b. Okay, so you are performing and operation on the input variables a and b. It is assigned to temp one. Then temp two is assigned c and d. C and d, they are the variables to this particular process. Then temp1 is equal to temp1 or temp2. Okay, so the ORing operation is done here. So like the higher level language, you can use this kind of assignment. Temp1 is equal to temp1 or temp2. Okay, so that is the statement 3 in this. And finally, z is assigned. Okay, now this is the signal assignment statement, which is the output. Z is the output, so z is assigned not temp one. Okay, so here it will be the end of the process. Now the statements in this particular process, they are executed sequentially. That means this statement one is executed first, then statement two, then statement three, and finally the statement four will be executed. Okay, and the process goes into the wait state, and this particular the statements are again executed when any of the values of A, B, C, D. So this is called the sensitivity list. So any of the value of the A, B, C, D changes, then uh, then these particular statements, they are executed again. Okay. So the first architecture body, which we declared, which we gave the name AOI concurrent, describe the AOI entity for the data flow style of modeling, whereas the second one, as we have discussed, it is for the behavioral style of type of modeling. Okay, so the a process statement, which is the concurrent statement, is the primary mechanism used for describing the functionality of an entity in this modeling style. Okay, so further in this particular topic, we shall be describing, or we shall be writing only the behavioral style of modeling, while in the next topic we shall go for the data flow style of modeling. Okay, still there is one more style of modeling, that is the structural style of modeling. Okay, no, because process statement is the primary statement that is used in the behavioral modeling. So let us see the process statement in the detail. The process statement contains sequential statements that describe the functionality of a portion of an entity in the sequential term. Okay, so in an architecture, you can write one or more statement. So if you are writing more process statements, then each of the process statement will describe the functionality of one portion of the entity. So there can be number of portions which describe the entity. The syntax of this particular process statement is like this. Okay, already one process statement we have seen. The process statement may have some label. Okay, so it is optional, so you can give the label or you may not give the label. So you can use some identifier for giving the label, and it is followed by colon. Okay, in the earlier statement, process statement, we did not use label, but wherever it is required, you can use the label. Then the process keyword you need to use whenever you are writing the process uh, statement. Then uh, in the followed by the process statement, you can write the sensitivity list. Okay, so this is the sensitivity list. So uh, to which particular events this process is sensitive is described in this particular sensitivity list. Then followed by that is the the begin keyword, or after that you can go for declaration of the item, which can be used in this particular declaration of the variables that can be used in this particular process. Then begin keyword is used, and uh, in that then starts the body of the process statement, and you can use various process statement. Okay, so these sequential statements can be used. So what are the different sequential statement that can be used in the process statement? It can be variable assignment statement, it can be signal assignment statement, it can be wait statement, it can be if statement, it can be case statement, it can be loop statement, it can be null statement, exit statement, next statement, assertion statement, procedure call statement, or return statement. So like that, different types of statements are there. Sequential statements are there, and we can use any of these particular sequential statement inside this particular process statement. Okay, and after we have written all the statements, then we have to write the end of the process. Okay, then here optionally again you can use that particular process label if we are using the label for that particular process. Okay, so let us see some example of this. Okay, so this is what we have already described with the process statement. So this is one example of this process use of the process statement, in which we are using a variable assignment statement. Okay, so the process keyword is followed by the sensitivity list. In the sensitivity list, it is the uh, signal A. That means if any event occurs with A. Okay, so what event can occur with A? The value of A, let us say it is bit value. Okay, so the value of A may change. Okay, so it may become 0 or it may become 1. Okay, A may be integer also even. Okay, so or it can be any signal. So if A changes, then event occurs. Okay, so whenever event occur, the statements in this particular process are executed. Okay, the variable that is used in this process, they are event on integer, event on A. So this is the name of the variable, event on A, and it is integer type of variable, and initially it is assigned the value 0. Then we write here the sequential statement. The sequential statement written is event on A is equal to event on A plus 1. Okay, so here the value of event on A is increased by whenever event occurs at A. Okay, so if A is a bit type of signal, then if A changes from 0 to 1 or 1 to 0, uh, the the event is said to occur at A, and every time event occurs, this particular event on A will be incremented by 1. Okay, so this is the process statement. Then the process statement. This is another process, or it is the same thing which is being described here, which we have discussed. Uh, the another example of the process statement. Okay, here it is using a label for the process. So before the process statement, signals are declared. Okay, A and Z, they are the integer type of signals. Then in between there may be some other statements. Then pz is the label that is given to this particular process, and A is there in the sensitivity list. That is, if A changes, then this particular statements in this procedure, they are executed. Okay, of course they are executed for the first time, and subsequently when uh, A changes, then this particular statement in this particular process are executed. So here the variables, two variables are declared here, v1 and v2. Then v1 is assigned a minus v2, three statements are written. Then z is the signal, so z is assigned minus v1, and v2 is assigned z plus v1 into 2. Like this, three statements are there, and then it is end of the process. Okay. So if an event occurs on signal a, let us say at time t1, then the variable v2 uh, would have been maybe assigned some value. Okay, so the value assigned to v2, it may be 10 in the statement 3. Then in that case, when the next event occurs at signal a, then at that time the t2 value uh, or the v2 value in the statement 1 would be still 10. Okay, that means this particular v2 or v1, they will retain the value when this particular process statement is re-entered. Okay, so when some event occurs, then this is signal assignment statement. You can use signal assignment statement inside the process. So the signal assignment statement, they can be written, or the syntax is greater than or equal to the left side of this particular signal assignment statement. It should be the signal object. Okay, and optionally you can write the keyword after in the signal assignment statement. So in the, you can see that in the first case after is not used. Okay, so immediately, or it will be assigned, this particular value will be assigned to the counter after a delta delay by default. Okay, whereas this PAR will be assigned PAR or DIN after 12 nanoseconds. Whereas so we are going to specify delay uh, after the after keyword. Okay, whereas this Z is assigned this particular whole expression, and it will be assigned after 6 nanosecond. Okay, so this is the signal assignment statement. Then you can have wait statement in the process. Okay, so the wait statement will wait on some they will wait on certain signals. Okay, so you can specify the sensitivity list here, or another form of wait is wait until some condition is uh, some condition is uh, you can say becomes true. Okay, or wait for time expression, so you can give some time expression here, or wait on, or you can make a combination of all these above statement. For example, it can be wait on the sensitivity list until some boolean expression is comes true, and for this much particular time. Okay, so it can be combination of all this on, until, and form for in the wait statement. Okay, so the different wait statements can be like this. Okay, different examples of the wait statement. So wait on A, B, C. So this is the statement. So in the first statement, it will wait till any event occurs on A, B, or C. The second statement is wait until A equal to B. So it will wait until A is equal to B comes true, and after it comes true, then it will go to the next statement after the wait statement. Then wait for 10 nanosecond, the third statement. So it will wait there for 10 nanosecond, and it will go to the next statement only after 10 nanoseconds. Then wait on clock for 20 nanoseconds. So it is the combination of on and for. So when uh, when any change occurs on clock, after that it waits for 20 nanosecond. Okay, whereas the third one is going to uh, is going to use the Boolean expression wait until sum is greater than 100. Okay, so after it becomes greater than 100, then it waits for 50 minutes when this particular expression comes true. Okay, so like this, we can make use of the wait statement in the process statement. Okay, so this already we have described statement 1, statement 2, statement 3, and statement 4. Okay, so we can use wait statement inside the process statement. Okay, now this is another example of the process. Okay, now the it is possible for a process not to have a and explicitly the sensitivity list. Okay, after the process, usually what we do is that we specify the sensitivity list, but here in this we have not specified any sensitivity list. But instead of sensitivity list, what we have done is that we have used this particular weight on A B C D. Okay, so what happens is that this particular process will be executed, that the statement in the process are executed. Okay, because there is no sensitivity list here, so they are sequentially executed up to this. But here what happens is that it is wait on ABCD. So the execution will wait here, or your simulation will wait here until ABCD are any one of this ABCD changes. After it changes or modified, then it comes out of this particular weight. And then because in the process there is no sensitivity list, so again it enters into this particular begin. Okay, and then again it executes this statement sequentially, and again for the second time again it waits on this A B C D. So it keeps on waiting till the next event occurs at this particular A B C D. Okay, so uh, uh, today we have discussed this entity declaration, architecture declaration, process statement, signal assignment statement, and wait statement with respect to this particular behavioral modeling. Okay, we shall continue with this particular behavioral modeling. In that we shall see if then else statement, next statement, for statement, and many other sequential statements are there. So that we shall see in the extra class which is scheduled at 1 o'clock. Okay, so I think you are aware that extra classes are being scheduled. So today we shall be having one extra class at 1 p.m., and we shall have another extra class tomorrow. Okay, of course, at 8 o'clock we'll have a regular class instead of that test, MCQ test, and we shall have two extra classes, 1 to 3 tomorrow. Okay, so if we conduct, or if you attend these classes, then sufficiently each and every topic of this particular unit is going to be covered. Okay, so we shall meet at 1. Till then, bye.
हेलो पेपर है ये तो
All of you now can proceed to join the next class.
भूषण लेफ्ट मारे सांगितलं. मार ना भूषण बोल ना. अरे लेफ्ट मारे सांगितलं.
अरे तू मार ना पहिले पण.
बॅक बटनच सापडत नाही.
स्विच ऑफ करतो मोबाईल.
तेज आहे का रे तेज?
त्याच्या पाळाला.
भाऊ तेजाला काल ताप आलेला हारली म्हणून.
107 वरच ऑल आउट झाले.
तेवढी झाली ते तरी बरं झालं.
अरे पहिले मला वाटलं 10-15 रन होऊनच ऑल आउट होत्या काय माहिती.
मला तेच वाटलं म्हणा 49चे रेकॉर्ड कमी करते काही नाही.
हा ना. 4 रन 3
तेज उठत नाही आता मुंबई इंडियन्सची मॅच होईपर्यंत.
भाई ओमकार
रेकॉर्डिंग चालू आहे.
मुंबईची
आजची मॅच मुंबई बरोबर आहे.
आज चेन्नईची वाटत.
टेस्ट यार का चंदूबाई.
कायची टेस्ट भाऊ?
ओपीजी.
आत्ता का?
मग कालच
भाऊ
सांगितलं नाही का.
रेकॉर्डिंग चालू आहे बरं का.
जाऊ दे रे कुठे 7 दिवस
टेस्ट इज इनेबल. टेस्ट इज इनेबल.
एकच टेस्ट आहे त्याला काही नाही. एक तास थोडा लागतो टेस्टला.
मला कळत नाही. एकानं ओके टाकलं तर माझं सगळंच काऊन टाकित ओके ओके ओके.
अरे ते असतं ना सपोर्टिव्ह म्हणून मागते.
अरे पण एक काल आता ते हे टाकलं काय रिव्ह्यू ओपन करा त्या विसल्या ना त्याच्या मागे टाकायची मी एस काय टाकायची.
गमे बोलत नाही. गमेला वाटतं रेकॉर्डिंग चालू पण चॅट पण सेव्ह होतात गमी.
हा ना. इधर
रेकॉर्डिंग
काय
फौजी आल्या का नाही? भरत्या आल्या का नाही तुमच्या? काही झाला का नाही तुमचं?
आता हाय वाटतं ना नाशिक.
आहे ना.
काय
मग जाणार नाही.
कारण कॉमन झालं आता.
हा ना आता ते एकदम थर्ड क्लास झाला करण. आता नवीन आणायला पाहिजे तेव्हा सुट्ट्या भेटतील परत.
चीन तयारी करू राहिलं पुढच्या वायरची. आता पाहू काय होत.
नकोय भाऊ सुट्ट्या कॉलेजेस परवडतं माहितीये का.
हा भाऊ खरंच.
जाऊ दे चला आता टेस्ट देऊन टाकू. परत सर्व्हर डाऊन झालं तर प्रॉब्लेम येत राहील.
बरं ठीक आहे.
हॅलो.